Hello everyone. Today we are going to learn about functional dependencies. Look at this, x determines y if the following holds for every pair of tuples t1 and t2 in R. That is, if t1 dot x is equal to t2 dot x, then t1 dot y is equal to t2 dot y, where x and y are the two different attributes. That is, x determines y essentially says that if two tuples agree upon a value in attribute x, then they must also agree on the values in attribute y. Now let's take up this example of relation called as student. If student ID determines student name is my functional dependency, then if two tuples have the same student ID, they must have the same student name. Remember, for a student ID of 101, at one row I have the value as name as Asha, and in another 101 I have the name as Usha, is not acceptable. That is a invalid dependence. So basically it is functional dependency is nothing but the relationship between two attributes. Typically we say it is between the primary key and the non-key attributes. That is, they are functionally dependent. See this part, x determines y. When I say the left hand side, that is x here, is called as the determinant and the right hand side is called as dependent. So y is dependent on x. So x can determine y. Now what is the importance? Basically functional dependencies helps you in normalization. Normalization is process of decomposing the table or splitting up of the larger table into smaller. Now how do I do it? Based on the functional dependencies. Normalization can basically help me in reducing redundancy and maintaining the data integrity. So functional dependency plays a key role in taking a decision as to how do I decompose the table or how do I split the table. So these FDs can also help you in query optimization and proper data designing, that is designing of the schema to ensure data consistency. Now let's learn certain rules of inference for the functional dependencies. Okay, with this I will be able to find the closure of the functional dependency, set of attributes and everything. So let's just try to understand these basic rules. There are three basic rules known as Armstrong's axioms, which are reflexivity, augmentation and transitivity. Reflexivity says if at all there is a functional dependency x, or otherwise I say that x determines y. If y is a proper subset of x, then x determines y holds good. So when you see that reflexivity, self-dependency, that is x determines x is always true. X determines x is always true, and if y is a proper subset of x, then x determines y. For example, if at all x is a composite primary key where I have student number and student name, then student number and student name can determine student name or can determine student number, because student name is a proper subset of the composite key student number and student name. Similarly, augmentation. If there is a functional dependency x determines y, then by adding a new attribute xz can determine yz for any z where z is a element from the set of attributes. So augmentation says if x determines y, then xz determines yz. Okay. Now the rule of transitivity. Here, if there are two functional dependencies, x determines y and y determines z, then the functional dependency x determines z holds. That is indirect. So I call this as transitivity. There is also certain rules. So these are basic rules or fundamental rules called as Armstrong's axioms. There are also additional rules of union, decomposition and pseudo-transitivity. Union is if x determines y and also x determines z, then X can combinedly determine Y and Z. Y and Z can be determined by X because of the rule of union. Decomposition. If X determines YZ, then I can split them as X determines Y, X determines Z. Pseudo-transitivity says if X determines Y and WY determines Z, these are two functional dependencies I have. Now if you see this W determines Y, WY determines Z, here the first FD says X determines Y. So I can always replace this Y with X so that I get a new dependency WX determines Z. This is called as pseudo transitivity. Replace this Y with X because of the functional dependency X determines Y. Let's come back to closure of a set of FDs. A closure of a set of functional dependencies is denoted as F plus. Now this is the set of all functional dependencies that can be inferred from the original set of F using Armstrong's axiom. That is, say for example, you are given a relation and a set of functional dependencies. Then using those functional dependencies, I'll be able to infer few more dependencies. So F plus is going to be a superset which can contain all these things. Okay, so basically the purpose of finding the closure is to understand all the possible dependencies that can be derived from the given set of functional dependencies. So where is it useful? If a particular FD is implied or not using the set of FDs, it is also used for your normalization process to ensure that certain properties hold. Now how to find this? Let me just show you this simple example. Assume that I have a relation with set of attributes as A, B, C, and two dependencies are defined. A determines B and B determines C. Then F plus, it will anyway include A determines B, B determines C. Apart from that, I can have another functional dependency added to it which says A determines C. That is, by the rule of transitivity, I can see to that A determines C also holds. Just show you this particular thing with the example here. I have the set of given FDs, A determines B, B determines C, and A determines D. I am asked to find A plus. So anyway, you know, by the rule of reflexivity, A can determine A itself. So A is first included. Now look at the first dependency here, first FD given, A determines B. Now because of this, A determines B and A is a subset of this particular closure, I can union A union, closure union B. So B is added into this list. Now take the next functional dependency, B determines C. B is already a part of this closure, so automatically C can be included into this. Now this particular dependency which says A determines D, because of which I can add D into this. The set of all the attributes of this particular relation was A, B, C, D, and all those have come into this particular set A plus. That is why A plus is, that is A is capable of determining A, B, C, D. So indirectly when I include all these things, it says that A is a candidate key. Let us look at this with respect to, say for example, attribute B. If I have to find out B plus, by default anyway B will be introduced. Now let me just check these attributes. I have A determines B, which is of no use for me. Let me see this B determines C. Because of B determines C, I can include C into this because B is already a subset of this closure, and I can include C into this. Do I have any dependency here which includes B or C? I don't have any more. So it just says that B plus contains only B and C. In such situation, it cannot be a candidate. Let me just show you another example here. Okay, another example. This is also in the similar way. Given a relation R with set of attributes v, y, z, w, and there are set of functional dependencies given. You are asked to find the closure of the attribute v. So automatically you will add v into the closure first. Then from this v determines z. You include z into the closure. Then from the relation Vz determines W, you add W to the closure. Then I have W determines Y, because of which I add Y to the closure. I don't even require other, because I have found here that all the attributes are a part of V plus. So hence no more repetition is required, because there is no more attributes that can be added to it. So indirectly I am saying that V is a candidate key. Look at this. There is a different set of functional dependencies given. V determines Y, W determines Y, and V determines W. And you are asked to find the closure of attribute V. So first I add V itself. In order to find V plus, I add V. Then my first dependency V determines Y gives me or allows me to add Y into the closure. Then W determines Y, it allows me to include Y into the, W determines Y, anyway not required because Y is already there. V determines W, allows me to include W. There are no more functional dependencies. See, this was F plus, which is the set of all the possible functional dependencies which can be inferred from the existing one. Still I see that there are no more functional dependencies. So my closure, that is V plus, will only contain V, Y and W. So hence I can indirectly say that it's not a candidate key. Well, let's just look into the types of functional dependencies quickly. There are 5 different types: fully functional dependency, partial dependency, transitive dependency, trivial and non-trivial dependency. Then I have multi-valued dependency. Fully functionally dependent. When there is a candidate key, or otherwise the so-called primary key, on which all the attributes depend. Now when I look into this particular example below here, see, project number and employee number can be a composite primary key here. Then there is only one attribute which is dependent fully on this, because see, the hours, number of hours you have worked depends both on the employee and the project number. Even if I remove one attribute from this, then I cannot define hour, because you just say project number and hour, you don't know who has worked for that many hours on that project. If you remove project number from that, you don't know employee has worked for that many hours on which project. So if at all, removal of any attribute A from X, if the dependency does not hold anymore, then you call it as, or then it is going to be fully functionally dependent. The second one is partial dependency. Partial dependency says the certain attributes, that is non-prime attributes or non-key attributes, are dependent only on a part of the primary key. Now if you look into this, if I say that employee number and project number are going to be your composite primary key, there are certain attributes which depend only on a part of it. For example, employee name is dependent only on employee number and not on project number. Similarly, project name is dependent only on project number and has nothing to do with employee number. So when I say this, the non-prime attributes, if that is non-key attribute is determined by a part but not the whole of a composite primary key, then I say that there is partial dependency. If you look into this, see here, project number and employee number is a composite primary key, but project name is dependent only on the project number, that is partial. Similarly, project employee name or job class or charges per hour is dependent only on employee number, whereas only ours is dependent on both project number and employee number, which we call it as fully functionally dependent. Transitive dependency, this is like if there is a functional dependency which is indirect relationship. It is like we already learnt about transitive relationship. See, look at this particular example. Project number and employee number are the composite primary keys. Employee number is dependent or determines job class. That is, which employee belongs to which type of job or which job class is determined by employee number, but the charges per hour for a particular job is dependent only on job class and nothing to do with employee number. How much you are paid per hour is dependent on the job class, which category of job you are in. Based on that, your hourly charges are decided. So here employee number determines job class and job class determines charges per hour. Hence employee number can tell you what is the charges per hour he is earning. So when I talk about this, this is called as transitive functional dependency. Multi-valued dependency is a special kind of dependency where for a particular value you have got multiple values in multiple columns. See, multi-valued dependency occurs in a situation where there are multiple independent multi-valued attributes in a single table. If you look into this, for a particular car model, the manufacturing years may be different. It would have been manufactured in 2017, 2018, 2015, same car model. And colors may also be different. In 2017 only you would have manufactured that car in multiple colors, and in 2018 also you have manufactured it in multiple colors. So there can be more than one value for both manufacturing year and color. So this kind of dependency is called as multi-valued dependency. We will see that this adds more rows into your table actually. A trivial functional dependency says that this set of attributes includes that attributes also. Now see, A determines B is trivial functional dependency if B is a subset of A. So anyway, A determines A is by default trivial and B determines B is also trivial. When I have A comma B determines B, this is known as trivial because B is a subset of this. So look at this, student ID and student name determines student ID, where student ID is a subset of this particular left hand side attribute. Okay. Non-trivial functional dependency, it is a dependency is true when Y is not a subset. Then this dependency is called as trivial functional dependency. That means it is fully dependent, like there is no part. Look at this, employee ID determines employee name, where employee name is never a subset of employee ID, but still it determines. This is called as non-trivial functional dependency.